All right, so today again we'll be talking about chapter 4 on sampling. And go ahead and get started. All right, so again, beginning of this section of PowerPoint slides, there's some thought questions, which are going to lead into the topic for today. What do you think is the major difference between a survey, such as a public opinion poll, and an experiment, such as a heartbeat experiment? Can anybody give their opinion about this? What they think the difference is? Okay. No one knows? All right.
The
So I'm not going to
results
give
of the experiment are probably more detailed.
more detail. Okay. So what do you mean by detail? What kind of detail?
Like more specific, like more planned out. It's kind of like a case study in psychology. Like it's more focused on less people.
All right. So you think okay. So there's more detail, but fewer participants. Is that right? That's what you're saying for experiment? I'm assuming that's what you said, right? I'm just summarizing.
Yeah.
Okay. All right. Well, we'll get to see if that's true or not. Anybody else have an opinion on this? Difference between a survey and an experiment. Okay. Well, let's move on. We'll get to know a little bit
One
about.
is much more controlled.
Oh, okay. Control. All right. Which one is more controlled? The
The
survey,
experiment.
the experiment. Okay. All right. There's more. You're controlling something in an experiment, right? Survey, you're not. Is that right? Is that what you're saying?
Yes.
Good. Okay. Good. All right. Well, let's see if that's true also. So we'll. So there's information about detail. Experiments are more detailed, and also there's more control. All right. Good. So go to the next thought question. Suppose a properly chosen sample of 1,600 people across the United States was asked if they regularly watch a certain television program, and 24% of them said yes. How close do you think that is to the percentage of the entire country who watch the show? Do you think it's within 30% of the right answer, 10%, 5%, 1%, or do you think it's exactly the same as the population? That 24% from the sample, how close do you think it is to the actual percentage for the population? I think that's what they're asking. Have any idea? Anyone? Okay. Well, I guess we'll find out about that also. Well, question 3. Many television stations conduct polls by asking viewers to call one phone number if they feel one way about an issue, and a different phone number if they feel the opposite. Do you think the results of such a poll represent the feelings of the community? Let's ask that first question first. What do you think? These are polls asking viewers to call one phone number if they feel one way and another phone number if they feel another way about a certain issue. Do you think the results that they get from this poll represents the feelings of the entire community?
It's probably the callers are probably only have strong feelings about it.
Good, 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 good. So that's it. That's part of it, that they're excited or interested in this topic, and maybe that's different from people who aren't calling in, right? And also, how about the television station itself? Does everybody watch that particular television station? Well, probably not, right? Probably not. So does it really represent the whole population. That's the idea. All right. Do you think they represent the feelings of all those watching the TV station at that time, or the feelings of some other group? Again, I think we're addressing those things when with your response just now, right? So it may not represent everyone. That's the whole point. Here's number 4. Suppose you had a telephone directory listing all businesses in a city, alphabetized by type of business. If you wanted to phone 100 of them to get a representative sampling of opinion on some issue, how would you select which 100 to phone? So how would you do it? Anybody have any ideas about that? Would you pick the first 100 businesses? Do you think that's a good idea?
Maybe do like every 5 businesses.
Good, interesting idea. So maybe have some sort of procedure where you do maybe every 20th or every 5th person on the list. Yeah. Well, let's see. You're along the right track there. There's a little something that has to be added to that, but that's very good. So you're not in favor of the first 100 listed, right? Is that right?
Not in favor.
No. All right. So we're going to see a type of sampling that deals with something like this a little bit later. All right. There are many professional polling organizations, Gallup and Roper, maybe you've heard of them. They often report on surveys that they have done, announcing that they have sampled 1,243 adults or some such number of people. How do you think they select the people to include in their samples? Anybody have any idea how they might do it? Okay. All right. So maybe 8 o'clock is too early today for many of you. That's okay. All right, here we go. Let's talk a little bit about the types of surveys, the strategies that are used to conduct them. Number 1, we know that a survey, a sample, is a subgroup of a larger population, right? And so we want to take the subgroup of the larger population and ask questions. That's typically what a survey is. With surveys, there's no intervention or manipulation of the respondents. So somebody talked about control with experiment. There's not supposed to be any control with sample surveys. Okay, they're simply being asked questions, right? And you're answering the questions. So that's all there is to it, apparently. Now, with what's called a randomized experiment, randomized meaning that if you have different treatments, maybe in an experiment, you randomly assign those treatments to the participants in the study. Right? So what you're doing is you're measuring the effect of manipulating the environment in some way. All right, that's control, right? That's the term control. Manipulation is assigned to participants on a random basis, however. So we randomly assign, so we come up with these so-called treatments, and then we randomly assign them to the participants. So we could, let's say there's 100 people in the experiment. We can list each participant from 1 to 100, give them a number, and then ask a computer maybe to randomly select maybe half of them to be in to get one of the treatments, and then the other half gets the other treatment. That would be a way of randomizing the treatments. Now, here's some important definitions here. It may show up on your quiz. And now you do have a quiz next week. I'll go over that at the end of today's session. But you need to pay attention to some of these definitions. An explanatory variable. That is the variable that's being manipulated. All right, we're making changes to that variable. The experimenter is purposely changing a variable. All right. So what could it be? Something like if the experiment is, we're looking at the ability of a new drug to cure a disease. Okay? And maybe there is an old drug that's been used and you want to see if there's an improvement with the new drug. So the explanatory variable would be what? Would be the drug, whichever drug that you give, the old drug or the new drug. It's the drug, it's a drug that's being given. Now the response variable is the outcome that we don't manipulate. Response meaning that it's responding to the explanatory variable. There's some that we think that the explanatory variable is causing an effect on the response variable. So what could be the response variable in the example I just gave? It's the disease, right? Does it make the disease less? Maybe you become less diseased, okay? So less of a disease than before. Maybe the new drug reduces disease more than the old drug. Oh, so the response variable is the change in the amount of disease that you get, all right, if you have this disease. But we don't want to manipulate that because we want to see if the explanatory variable is causing a change in the response variable. Now, what does randomization do when we randomly assign treatments to different groups? By doing this, at least the theory is that we make the groups approximately equal in all other respects other than the explanatory variable. So the two groups have, they're approximately the same ages, the same genders, things like that. All right, you can understand what I'm saying, and therefore any changes to the response variable will strictly be due to the changes that you impose on the explanatory variable. Okay, so that's the whole idea. Now, an observational study, there's no manipulation, and if there is any, it's occurring naturally and within the environment, not by the experimenter. All right, so there's no imposed control. You also, in an observational study, this is very important, you cannot assume that the explanatory variable is the only variable responsible for changes in the response variable. It could be other variables that could be causing the change in the response variable. But because we are not controlling anything in an observational study, it's possible that a change that we see in the response variable may not be due to the changes that in the explanatory variable. It could be due to some other variable. Now, a particular type, the book goes through this in more detail, a particular type of observational study is called a case control study, where you are, even though it's observational and you're not manipulating anything, you are comparing the two groups that one group has the some aspect of the explanatory variable, and then you have a control group that doesn't. But there's no random assignment in this case here, just like an experiment. No random assignment is occurring. You don't randomly assign people. It's a natural setting, so we we select people. Now, of course, in the selection process of getting people into the study, we will be, of course, randomly selecting them to be in the study. But once they're in the study, for example, if we want to see people, let me think of an example here. Maybe people are naturally taking a new type of drug. They're not being assigned the drug, but they are taking it. And there's other people who don't take this drug. We want to see if it has some effect maybe on blood pressure or something like that. So in a case control study, we randomly select people to be in the group that takes the drug, and there's people, and the other people are going to be in the group that doesn't take the drug, but this is naturally, this is their choice. The experimenter did not assign people to those groups. All right, now, what's the advantage of an observational study is that if we randomly select participants to be in the study, or randomly select people to be in the study, if we're creating our own data, then we could possibly extend the results to the real world, all right, to the whole population. An experiment, normally we may not be able to do that because it's artificial, number one. Some artificial manipulations going on. And number two, many times we have volunteers that come into the experiment. They're not randomly selected. So that's why an observational study might be superior, because we can at least extend the results to the outside world, and with an experiment, we may not be able to do that. All right, here's a fancy term: meta-analysis. Meta-analyses. What are they? What are meta-analyses? These are, it's basically a study where we collect a whole bunch of other studies that were done in the past, and we analyze them to see if they lead to some conclusion. And it should be about the same, about a similar topic, obviously. It should, and it's just a statistical way of collecting other studies and analyzing them and coming to a conclusion about all of them. We might be able to see patterns or effects that were not easily seen in each individual study. All right. So in your textbook, they go into this concept of meta-analysis in chapter 25. For this course, you just need to know the definition of it right here. All right. We're not going to go into any. We might look at it if we have some time, but typically we run out of time because Rowan University doesn't have usually as many instruction days as other universities. So we usually don't have time to go to chapter 25. So you just need to know, again, the definition from the slide here. Case studies. Now, a case study typically is an in-depth examination of one or a small number of individuals. All right, we can never extend it to the whole population. Now, why do we want to do a case study? The reason is because maybe we'll get an idea of, let's say we're going to create a survey, right? We're going to create a survey that we're going to give to people. By doing a case study, we're going to be able to maybe figure out the types of questions we can ask them, all right, by what their answers are in the case study. In other words, we will be able to come up and create a questionnaire that will be appropriate. So these case studies are descriptive in a sense that we can describe what the individuals are experiencing, but we don't use statistical methods with case studies. Again, the purpose of it is just to get some information so that we can create a in-depth study later on. So we can't extend the information to anybody else or to the larger population. That's not the purpose of it. All right. So now we're going to look at some different types of studies and experiments and observations, just so that you can see the difference between the two. So here's one news story. It says, eating organic foods reduces pesticide concentration in children. Eating organic foods reduces pesticide concentration in children. So it's an observational study because in this case, it's based on a diary that parents keep for their children, and they record what they eat over 3 days. All right. So observational meaning the experimenters are not assigning what the participants are going to eat. All right. Parents are just keeping a food diary for their children. And what result do you see? There was a difference between children eating organic versus conventional food. So what is the positive result from this? What's the advantage of doing it this way? Well, the children were following their natural diet. All right, it's a natural setting. It's not a controlled setting like an experiment. What's the disadvantage? That's what they mean by minus. What's the disadvantage? Well, you really can't determine if the difference is due to food choice or other factors. In other words, if we were looking at the amount of pesticide concentration in children, I guess they take a blood test or something to determine that. The fact that the study conditions were not controlled, it could be that the difference in pesticide concentrations has something to do with something else and not with the diet. Right? So the takeaway from the observational study here is you cannot assume a cause and effect relationship. In other words, eating organic foods reduces pesticide concentration. We can't come to that conclusion. All right, we may say there is an association there. It seems as if eating organic foods is associated with reduced pesticide concentration in children, but we can't assume it's causing it. It could be another factor. All right, let's look at the next one. It says rigorous veggie diet found to slash cholesterol. All right, now this is an experiment. Now they say volunteers are randomly assigned to one of 3 diets, and what was being measured is a reduction in cholesterol. All right. So what was being assigned? What was being assigned? The diets. Who's assigning it? The experimenters. This is not a natural setting. All right. So you can see the difference here. It's an experiment. We're randomly assigning these diets to individuals, and we're going to see if there's any difference in cholesterol being measured. Now, because we're randomly assigning across these different groups, there's 3 groups, right, for the 3 diets, we should be able to come up with a cause and effect relationship, because by randomly assigning it, we're assuming that the other variables that could be influencing cholesterol are about the same in each of the groups. Okay, so there's not going to be any differences necessarily any difference between among the groups regarding these other factors. The only factor that's different is the diet. So that's the positive part of this. We can talk about cause and effect now. What's the negative? Well, there's a couple negatives. The one that's mentioned here is, would anybody really follow that particular diet in the real world? All right, remember, this is a unnatural setting. So that's one negative. The other negative I'll just point out to you, and you'll find out about it later, is that the participants were not randomly selected for the study. Notice that next to the word experiment here, there's the term volunteers. Volunteers are not randomly selected, right? These are people you put out an advertisement, and they are the ones who actually volunteer for the study. So they're not being randomly selected. So that's the other problem. Because they're not being randomly selected, you can't generalize the results of this experiment to the larger population. That's one of the negatives also of running this type of experiment. All right, so let's talk a little bit about some of the vocabulary that's used in research studies. Okay, when we use the word unit, what we're really interested in is who or what is having the measurement on it. Okay, in other words, is it a person? Is it a fish? Is it a computer? Whatever the unit of measurement is, that is the unit. All right, so the unit that's being measured, I should say it that way. The unit that's being measured is what we mean by unit. It's that person or thing that we're doing the measurement on. Now, the population is the entire collection of these units about which we want information. All right. And when we do a sample, we're just collecting a subset of the units from that population. All right. Is everybody clear on that? Now, the population could be any population, usually in a problem, in a word problem. It'll define the population. It'll tell you what the population is. Even if they just talk about the sample, they'll describe it, and you'll know that that is not the sample itself, but the description of the sample, the types of people, or the types of fish, or computer, whatever it might be. That is the description of the population from which the sample is chosen. Now, here's a term that you should know, all right? Sampling frame. Sampling frame. Now, why is it that we use this term instead of population when we talk about choosing units for our sample? So this sampling frame is a list of units from which the sample is chosen. Well, let's talk about, let's say, who lives in the United States. You may not be aware of this, but there is no one list of people living in the United States. Now, in Europe, in smaller countries, there are lists. There's some of the Norwegian countries, they do know who lives in that country because they have a list of them. But there's no such list in the United States. So what has to be created is what's called a sampling frame. So for example, if they wanted to interview people, let's say the Census Bureau, which is a government agency that interviews people, if they wanted to interview people, they probably would have some sort of list of households, okay, in a particular geographical area. So their units that they're sampling are households. So they might be able to find households in a certain area. So the sampling frame is some list that typically is created to help in finding individuals for the survey. So the list is in place of the population. Now, what is the issue? Well, you hope it is the whole population when you create this sampling frame, but many times it will include people who shouldn't be in there, and it will exclude people that should be in there. All right, so it's not perfect, but that's the list of people, list of units from which we choose to sample is called a sampling frame. So this typically I do have an exam question on this, possibly in the final also, sampling frame. So make sure that you understand that this is the actual list from which the sample is chosen. Now, once we've chosen the sample, and we have a survey based on that sample, measurements are taken on the subset of from this population, or literally from the sampling frame. So a sample survey is a subset of the population. A census is a survey in which every unit or every person in the population is measured. So a sample survey is a subset of the population. A census is a survey of the entire population. Now, if we have Rowan, let's say our population is Rowan University students, and suppose we wanted to survey GPA for each student. Well, they wouldn't necessarily need a sample survey for this because Rowan University has the GPA for each student, each of the 10,000 or so students at Rowan. So if we wanted to find the average GPA for Rowan, we would just do a census. We wouldn't have to do a survey. However, let's say we wanted to, for some strange reason, we wanted to find the average height of students at Rowan, and we don't we don't ask for that information normally when a student enrolls. Well, we probably are not going to try to locate and ask all 10,000 students. So in this case, we would probably do a survey, a subset of the Rowan students, and ask them in the survey, how tall are you? So that is an example of why we might want to do surveys, because it's inconvenient or probably impossible to get the information from the entire population. All right. Any questions so far? Are we all good with the definitions? Again, you have access to these PowerPoints. I post them. Please read the textbook, however. All right. Don't try to use only these slides to study from. The slides are incomplete. They don't include everything, but they include enough to give you a general idea of what's in the chapter. All right. Now, another government agency besides the Census Bureau is called the Bureau of Labor Statistics. And they also do sample surveys. So it says here that they occasionally visit 60,000 households for a particular type of survey. And it's chosen from the list of all known households in the country. Now remember, no Bureau of Labor Statistics doesn't have a list of all people in the country, but they do have a list from various sources. They create a list of all the known households in the country. So each adult is classified as, when they're surveyed, as either employed, unemployed, or not in the labor force. They put that in quotes there. Now then, from that information, they calculate, and they do this monthly, they calculate the unemployment rate. So what is the unemployment rate? It's the number of unemployed persons divided by the sum of the employed and unemployed. Notice that what's not included is not in the labor force. So those people who maybe have given up trying to find work, they are not included in the unemployment rate. So the unemployment rate, in a sense, is underestimating the number of people who are actually out of work by a lot. Anyway, here are some of the these are some of the definitions that we talked about here, and we're going to describe what they are based on the Bureau of Labor Statistics sample. Now, what are the units of measurement? It's the adults in the labor force, all right? Even though we are sampling households, ultimately we're going to be asking individual adults the questions, right? And so the units from which we measure, in this case, we ask about employment, will be the adults in the labor force. That's the units. So the population of these units are all adults in the labor force. All right, is everybody clear on that? So the units are those individuals or things that we are measuring, that we are taking measurements of. And a measurement in this case is not, we're not measuring their height or anything. What we're doing is we're asking them questions, all right, in the survey. The population of these units is what the population is, all right? It's all adults in the labor force. Now, we could also talk about population of measurements, right? Would be the employment status of everyone in the labor force. So we could look at, population in two ways here. Population of the people who are being asked the question, and the population of the actual questions that are being asked. Now, sampling frame. The sampling frame is the list of what? In this case, it's a list of all the known households. So what are we actually sampling here? We are sampling from what? The households, all right? So that is the list that we are sampling from. So the population of units may not match the sampling frame. The sampling frame, again, is the list of whatever that we are acquiring the information from. In this case, it's a list of households in the country. All right. Now, ultimately, from that sampling frame, we're going to have a sample of what? of the units that we want to ask the question about employment status. So the sample of units are the people who are being asked the question about their employment. Right? Notice the sampling frame, the list from which we are choosing, ultimately the sample, is all the known households. So be careful with that. And then the sample of measurements, of course, is for each person that's being asked the question, it's the sample of the employment status of each person. So that would be the the variable that we are acquiring. Yes or no, or basically, are you employed or are you unemployed or you're not in the labor force? One of those answers. That's the measurement that we're doing. So many people, when they are told about sampling, that, for example, you can have a sample of 1,500 adults and it would represent 10 million people. Most people would say, that sounds ridiculous. How can you possibly take the results of a sample of only 1,500 people and say something about 10 million people? That's ridiculous. That's what most people would think, and that's probably when polling seems to not work very well, that's the reason they usually say, because it's stupid. They'll say something like, that's stupid. It doesn't make any sense. How can results of 1,500 people summarize the whole population? But it does work well. And the reason why polling doesn't work very well, I'll talk about it in a minute. It may be due to other factors, not due to the fact that sampling in its essence really works. Right? One of the things that we can do that we'll find out is that we can actually take our sample results and ultimately we can estimate the population results within a small percentage. We'll get to a very close answer. Now, it won't be exactly that result. I think there was when we started these slides today, there was a question about that, right? If we did a sample, we got, let's say the sample was the percentage of people in the population who have a certain trait or opinion, all right? Will that match the population percentage? Well, it won't, probably. But will it be within a certain percent? Well, if it's done properly, yes. We can get our answer. We have a very high probability that our answer would be within a small percent, like 3%. For example, if we think, let me give you an example. If our sample says that, let me think about this. I'll just come up with hypothetical. Let's say 80% of people in the sample think that coronavirus, we will be out of the pandemic by the end of the year, right? 80% in the sample think so. Well, if the sample has 1,500 adults and millions of people, is the entire population, then what typically happens is that if the sampling is done correctly, that 80% is going to be within 3% of the true population population percentage by a probability of about 95%. There's a 95% chance that your answer, the 80%, is within 3% of the true population percentage. Okay? What does that mean? Well, if we take the 3% and add and subtract it from the 80%, it would say that there's a 95% chance that the true population percentage of people who think the pandemic is going to end by the end of the year is between 77% and 83%. Where did I come up with those numbers? I took the 80% and subtracted 3%. I took the 80% and added 3%. And that's how I came up with that range, 77 to 83. All right. So this is how sampling really works. It doesn't give you the exact amount the population has, but it gives you it ultimately will give you a range of values and say with a very high degree of probability that the population is somewhere in that range. All right. And that is actually pretty good. That's very good if you can do that. Now, it says at the bottom of the screen here that this result does not depend on how large the population is, typically, we do want to make this work well. We do want the sample, the size of the sample. When we say size of the sample, we mean how many people, let's say, are in the sample. We want the size of the sample to be typically something like less than 10% of the size of the population. All right. But it doesn't depend on how large the population is. Right? It doesn't really depend on it. It just depends on how the sample was constructed from the population. All right, so here's a little bit of an approximation. Now, if you were taking a course in statistics, that is Stat 1, instead of taking this course, we would be going, first of all, we wouldn't be talking about this yet. This is something that's covered later in the semester in that course. But we would be talking about something called the margin of error. And we would actually be calculating it using our using a TI-83 or 84 calculator, and I'd show you how to do it, and there'd be a formula for it, all of that. Well, in this course, we're not going into that much detail, but in this case, in this chapter, they give you an approximation, what they call the margin of error. Now, what is the margin of error? Well, in the previous slide here, when they talked about, they say within 3%, they're saying the population percentage, all right, the sample percentage should be within 3% of the population percentage. What they're really referring to is this thing called a margin of error. They're saying, well, I know that the sample percentage is probably not going to be equal to the population percentage, but plus or minus 3%, it's going to be pretty close to be in that range. That's what they're saying here. They're saying the margin of error, the way to figure it out, approximately, is it's the amount of the margin of error is based on the sample size. And the small n there in that formula is the size of our sample. So suppose we have 100 people in our sample. 100 people. Right? So 100, n is equal to 100. Now, what is the square root of 100? That's 10. So our denominator, if we have 100 people in our sample, the denominator of that equation, margin of error equation here, is 1 divided by 10. 1 divided by the square root of 100 is 1 divided by 10. Now, what is 1? If we want to convert 1 divided by 10 into a percentage, right? Into a percentage, that would be what? Well, that's 10%. And therefore, our margin of error would be 10%. So if we only had 100 people in our survey, 100 people in our survey, then our margin of error would be approximately 10%. And that means if our sample, the percentage of people in our sample who think the pandemic will end by the end of the year is 80%, then we just take our 10% margin of error and add and subtract it from that 80%. And therefore, it would be 80% minus 10%, which is 70%. And then 80% plus 10% is 90%. Therefore, between 70% and 90%, we would be almost certain that the population proportion is in that range. Population percentage is in that range. But they're saying here, what if we wanted to have the margin of error less than, let me see how they phrase it. The sample proportion differs from the population proportion by more than the margin of error less than 5% of the time, or in fewer than 1 in 20 surveys, all right? Fewer than 1 in 20 surveys. Okay. Now let's just do an example of this. Let's just see how this works. Now, what they're really saying here is there's a 95% chance that the true population proportion or percentage is in the range that I just talked about. The sample percentage plus or minus the margin of error. So let's just, I think they give an example here. It'll make it hopefully clearer to you. Suppose you have a sample of 1,600 people. So n is 1,600. So our margin of error formula is 1 divided by the square root of n. So we just plug in 1,600 for n into that formula. And it ends up being 1 divided by 40, because the square root of 1600 is 40. And if we use our calculator, 1 divided by 40 is 0.025. 0.025 when converted into a percentage. Now, if you have a decimal and you want to convert it into a percentage, you multiply the decimal by 100. Hopefully you all know that. When we multiply 0.025 by 100, we get 2.5%. So that is our margin of error, 2.5%. Now suppose we asked the 1,600 people in our sample, right? Do you support the president's economic plan? So we ask all 1,600 people, and suppose 55% of the 1,600 people say yes, they support the president's economic plan, which means 45% either said no or they have no opinion. Make sense? So we know the margin of error is 2.5 percentage points for a sample of 1,600, right? That's what we calculated up here. So if our sample result is 55%, then we can, what we do is we take that 2.5% margin of error and we subtract it from 55%. And that's how we get 52.5% here. And then we add it to 55%, and we get 57.5%. All right. And then we can say something like we're almost certain. When we say almost certain, you're basically saying 95% certain. 95% certain. We're almost certain that the true population percentage of people support the president's economic plan is somewhere between 52.5% and 57.5%. We don't know for sure what the percentage is, but we have a pretty good idea it's between these two values. 95% chance, right? What does that mean? That means there's a 5% chance that it's outside of these two values, right? It's either less than 52.5% or greater than 57.5%. And that's what they mean by 1 in 20 times. 1 in 20 times means 5%. All right. So when we say almost certain, we're saying 95% certain. That is population percentages between these two numbers. But we are 5%, there's a 5% chance, or 1 in 20 chance, that this interval does not contain the true population portion. I like the 95% odds there, don't you? Don't you like the 95% chance that the population percentage is somewhere in between these two values? I think it's pretty good. And that's how most political polls work. When if you hear through the media, let's say in the past election, if you heard the polling, you know, with Biden versus Trump, they would give you a percentage, but also they would also say, if they were the media people were doing their job, they would say, oh, there's a margin of error of 4% or 5%, whatever they would say. Well, that's what they mean by that margin of error. They're talking about this. And what you're supposed to do as a consumer is you're supposed to take that margin of error and add it and subtract it from the sample percentage that was given, like we did here. That's really what you're supposed to be doing. And then you're going to say something like, there's a 95% chance that the population of voters would have voted between these two percentages, you know, for either Biden or Trump. That's what you're supposed to do, all right? And that's what they're illustrating here. All right, so any questions about this? This is something new. You've probably never seen this before. But I want to make sure that you understand what I talked about. Any questions? And this is about all you need to know about margin of error in terms of a formula. If I ever ask you about a formula, is that you can calculate this, and it's calculated pretty easily. Just put in your sample, the size of your sample, into the denominator, take the square root of it, and then take 1 divided by that, and you'll get a decimal and convert it into a percentage by multiplying by 100, and that'll be your margin of error. It'll be a percentage.
Is that on the quiz? I don't get this.
On a quiz, it'll be on your test. There'll be one question on your test.
Oh.
So again, if you have trouble with this, just get yourself a tutor. All right, make sure that, Rowan offers tutoring, and they'll go over, several examples of this until you say, oh, okay, I see what's going on. But here's another example. Here's a second example here. Actually, this is the, here's another example right here. Let's do one more, all right? And if you still don't get it, get a tutor and work it out with your tutor, because you'll ultimately get it. Maybe you'll need to spend a half an hour on this and then say, all right, I get it. All right, so you'll need like maybe 10 examples instead of 2. All right, so this has to do with drug use in kids, this particular study. So here you go. 1900, this company here, QEEV Analytics, it's just a research company. They surveyed 1,987 children. Now that's what small n is. The number, we use the term sample size. It's the number of people in the study, all right? So 1,987 children ages 12 to 17. They also surveyed 504 parents, all right? So there's 2 groups of people here, right? There's the children and the parents, and they both have different size samples. 1,987 children, 504 parents. They're 2 different groups. The margin of error was plus or minus 2 percentage points for children and plus or minus 4 percentage points for parents. Now they're rounding the percentages here. They're saying approximately, right? Let's see how they came up with that. Well, for children, it's just 1 divided by the square root of n. 1 divided by, how many children are there in the study? 1,987 of them. So 1 divided by square root of 1987, if you use your calculator, that's 0.0224. You round to 4 decimal places. And then if you multiply that by 100, that's 2.2%, approximately, right? You could say 2.24%. I don't know why they rounded it to 2.2, but that's what they did. I would have rounded to 2.24. For parents, well, there's 504 parents. 1 divided by the square root of 504 is 0.0445. Multiply that by 100, 4.45%. All right, so this is the margin of error for each of these groups. Note again, once again, the margin of error depends on what? Sample size. Size of your
So I have a question
Yeah.
about the study result. How did they get 20% and then 18% and 20% of all teens? Where did that even come from? That has nothing to do with the answers that we got.
Good. All right. Good question. First of all, they did a lot of rounding here in the slide. So, but I'll show you. All right. It's a good question. All right. Suppose for the children, forget about the parents for now. Suppose that they asked the children about buying marijuana in an hour or less, and they said 20% of the children said yes, they did, or teenagers. Hopefully they're not too young, right? So in the 1,987 children were asked, did they buy marijuana in an hour or less? And 20% of them said yes. All right, is that clear what that means? 20% of the 1,987 said yes. That means 80% said no.
Okay,
Right.
yeah, that makes sense.
Good, good. Now, what we want to do now is say, all right, now that I know for the 1,987 children, ages 12 to 17, which are, preteens and teens, right? We can pretty much say teens. What can we say about the percentage of the population of children between 12 and 17? All right, we just got the result from the sample, we got 20% of them. Well, what do? We take our sample result and we add and subtract from it the margin of error. That's all. When we subtract the margin of error from our sample results, we get the lower end of the interval, the range of numbers. And then when we add the margin of error to the 20%, we'll get the larger one. Then that's where they got the 18 to 22%. It's kind of rounded, I would say. What they're doing is they're saying, all right, 20% minus 2.2%. Now they rounded it just to 2%, they got 18. But if they, if you pick 2.2, you might as well use it, right? So what you should have gotten was 20 minus 2.2. It should say 17.8% here. All right. So what they did is they took the 20% and subtracted the margin of error for children, this one right here. And they just rounded it, and they got 18%. And then they took the 2.2% and added to the 20%, and then rounded it, and that's where they got the 22%. So the person who asked the question, does that make sense now, where they got these two numbers from? Whoever you are, I don't know who you were, who said that, asked that question. I hope you're still signed on. Hope I didn't lose you. But that's how they came up with these numbers. Now, it's a little confusing because
Excuse
all right,
me, you
you're
said
there.
there's only going to be one. No, this is Anika. You said there's only going to be one of these margin
Yeah.
errors.
If there's anything like this on your first test, it'd just be one.
Uh,
All right, it's not that much. All right, don't worry about it. But basically, you take your result from the sample and you calculate your margin of error, express it as a percentage, and you simply take that percentage and subtract it from and subtract that number from the 20%, the sample result, and you get this number, and you add it, the margin of error, to this number, and you get this number. And basically you're saying something like you're very confident, like 95% confident, that the population percentage is somewhere in between these two numbers here. That's the whole idea. You're saying something about the population based on the sample results. That's how they come up with answers about the population. All right. Now, again, if you were taking a regular statistics course, there would be a formula. You would plug the numbers that you get into the formula. You would need to know some probability theory to do it. Not much, but a little bit. Use your TI-84 calculator, and you come up with a more precise answer than this. This is more of an approximation, but it's pretty good approximation. Works pretty well. All right. So again, don't worry about it, but if you know how to do this, it's not that hard. It's pretty easy to do. But again, if it's confusing to you now, don't worry about it. It's only one question, possibly one question on the test. All right. Now, let's look. Here's some other information here about advantages of sample surveys. Suppose this first one here says, when measurements destroy the units being tested, a census is not feasible. What do they mean by destroy? Well, suppose you're a manager on an assembly line. Let's say what's coming off the assembly line is a box full of a product, all right? It's a box with product in it. And you want to check for defects. You want to see if there's anything wrong with the product. Well, you're not going to open up every single box, right, and check every product. That's stupid, right? Then you have to put it all back in again, and that wouldn't make any sense. So you want to sample a small percent of those boxes to check for defects, because if you measure whether the item is defective or not, you're sort of destroying the item. So that's why we don't want to do a census. We don't want to open up every box, because then we'd be destroying everything we produced. So that's one advantage of the sample, is that we can check for defects. Number two, it's faster to collect a sample than a census. Pretty obvious, right? If we were taking a sample of people of the United States, it's easier to sample them than to ask every person in the United States. Number three, we can devote resources to getting the most accurate information from the sample, right? Instead of trying to get as many people as possible, we want to devote resources to getting accurate information, and taking a sample is one way of doing that. All right, here comes we'll spend the next 10 minutes on these items here. Now, one thing I want to mention to you, besides this particular video that will be created from this session today. Last semester, when we did this chapter, for some reason, I couldn't do the class in person that day, so I recorded, I pre-recorded this chapter, all the information in it. So you have the advantage also having an additional video to look at, and that video is uninterrupted because it was pre-recorded. So you could look at that also. Maybe I gave different examples or something. Maybe the way I said it in that video makes more sense to you than this video. Who knows? You can take a look at that one too if it helps. But that's posted in Canvas right now. But anyway, what we want to do when we do sampling, we want to do what's called probability sampling. All right? What does probability sampling mean? We want to ensure that everyone in the population has an equal probability of being chosen for the sample. That's what probability sample, right? Now, it says here has a specified chance of making it into sample, but in most cases it's an equal probability. So we'll just say equal probability. I think most of you kind of know what that means. Now, we'll talk about the different types of random sampling. When we say probability and random, we mean the same thing. Simple random sample, every conceivable group of people of the required size. What do you mean by size? The number of people in the sample. If we say there's 100 people in the sample that we want, that's the size of the sample. That's what they mean by required size. So every conceivable group of people of the required size has the same chance of being the selected sample. In other words, if we could list, let's say we have a population of 1,000 people, and we want to take a sample of 50 people. If we could list all possible samples of size 50 from that population, if we could conceivably list them all, there could be billions of these samples. We could list them all. What simple random sample is saying is if the sample that we choose of 50 people, the ones that we get, the probability of getting that should be the same probability as getting any of the other possible samples that we could have gotten. That's really what they're saying. All right, what do we need to do simple random sample? We need a list of units in the population, right? In other words, we have to be able to number them. And we want to have some source of random numbers. Now, what do we mean by that? We can ask a calculator, we can ask a computer. They have these tables, but whatever. Let's say we ask a computer to, let's say we want, again, a sample size 50 people in sample. All right, and suppose there's 1,000 people in the population. So we number each person in the population 1 up to 1,000. And then we ask the computer, pick 50 numbers randomly from 1 to 1,000. Whatever numbers come up, whatever person that is in the population that was assigned that number gets chosen for the sample. Does that make sense? It's like if we had a big enough box, we wrote a number from 1 to 1,000. We wrote a number on a piece of paper. We'd have 1,000 pieces of paper, throw it into a box, mix it up with our hands, and then one by one pick 50 pieces of paper out. And whatever number shows up, that's the person who gets chosen for that that sample. So if I'm number 920 and 920 gets selected from the box, I'm one of the 50 people that gets into the sample. So it works like that. All right, makes sense. I think most people would understand that. But we can use a computer to do it instead of a box. Writing numbers on papers, we can have a computer randomly select 50 numbers from 1 to 1,000, and those people who have those numbers would be selected for the sample. All right, here's an example of this, all right? Just to sort of get you to understand what's going on. Suppose we have 200 students in your class, so it's a large class, that's your population, and you plan to take a simple random sample of 25 of those 200 students. So what do? You assign each of the 200 students a number, all right? And then you have a computer, maybe, select 25 numbers from 1 to 200. And whichever numbers are selected, if that student has that number that's assigned to them, they get chosen for that sample. All right. So there's a couple things that are being done here in this slide here. Number one, margin of error. Margin of error is the 1 divided by the square root of the size of the sample, not the size of the population, the size of the sample. So 1 divided by square root of 25 is 1 divided by 5. So the margin of error is 0.2. And you use your calculator, or 20%. So step 1, you obtain a list of students in the class, number 1 to 200. Obtain 25 random numbers. Again, if you do it with pieces of paper, you can do it that way. You're going to ask a computer to do it. All right, so you select your 25 students by doing that, and then you locate and interview the people on your list whose numbers were selected. Okay. Then
Is the square root always going to be 25?
no, it'll be the number of students in your sample. In this case, 25. If you, let's say you wanted a random sample of 10 students, then it would be 1 divided by the square root of 10.
Oh, okay, I got you.
Yeah.
Okay.
Now, why do you want to calculate the margin of error? Because suppose these 25 students, you're going to ask them a question. Yet, let's say, just make it simple, a yes/no question, and you want to know how many of them said yes to the question. And suppose in this, suppose out of the 25 students suppose 12 of them said yes to a question. Well, 12 is how many? What's the percentage of 12? That's 48%. So 12 out of 25 is 48% of the students, right? I believe that's true. So 48% of the students said yes to the question. Now, what is the, if you wanted to say, all right, what percentage of the population would say yes? With almost certainty, with 95% certainty. Well, you would take that 48, you would take that 48%, which is your sample percentage, and add and subtract what? The 20%, the margin of error. So 48% minus 20% would be 28%. 48% plus 20% is 68%. So you say somewhere between 28% and 68% of the students, of all 200 students, would say yes. All right, to that question. Now, it's about time to stop. Now, what I'm going to do, because there was many questions here, and I know that for some of you, this was probably a little bit, you need some time to digest what we went over today. I'm going to stop here, and I'm going to move the quiz to next Thursday, not Tuesday. And what I'm going to do is give you time to watch today's video, watch the video that I did last semester, and then I'll spend about, I'd say, 10 to 15 minutes at the beginning of the next session, finishing up this chapter here. And we'll have the quiz next Thursday, which will cover everything we covered in chapters 1 through 4. All right. So it'll give you some time over the weekend to digest some of this. Because if I added this right now, I'd be squeezing it in, and you would be probably like, oh, too much. So we're going to stop right here, and I'll add.
Can I ask how many questions? How many questions?
On the quiz? 5. What they are basically 5 statements, definition type statements, where it'll be pretty much out of your textbook. It'll be a definition, and I'll just leave something with a blank in it, and you just fill in the blank. You just type in the,
Okay.
yeah.
So
And it's
you
basically out
said
of your
only
textbook.
5?
5? There's 5.
You said only 5?
Well, let me explain. Each of the 5 statements will have either 2 fill in the blank phrases or words, or 4.
Okay, and is there a word bank or no? I'm
No
assuming
word bank
no.
because I used to do word banks when I gave the quizzes closed book.
Okay.
It's open book.
Okay, cool. Thank you.
Yeah, you have access to your book. So make sure you read the book and tag the book where you see the definitions so that you can easily find. And believe me, the quizzes are nothing more than me asking you to read the book. That's all it is. It's kind of forces you to read the book. If you want to do well in the quizzes, you read the book and you make sure you know where all the answers are, for the definitions and things like that. Now, on the quiz, I can tell you, I am not going to ask you in the quiz about margin of error. That will show up possibly on your first test. All right, so I'll leave your concerns about that. That will only show up on the first test. So there's time to, if you need tutoring with somebody, there's time for you to grapple with that and figure out how to do that. All right, the tutor will make it clearer to you than I can, because I have to make sure I cover all the material. I can't, spend lots of time on one topic. So that's what a tutor's there for. The tutor will make it clear to you. All right. So I'm going to stop here again. I will post this video later today, but you have that other video to look at, and then I will finish this up and then go into chapter 5 next time. Finish chapter 5 next Thursday. I will be doing that. Chapter 5 will be next Thursday, and then the following week is when we have a review, another quiz on following Tuesday after that, and then we have our first test. It's all on the schedule. You'll see it. All right, so that's it for today. Again, the only thing yeah, go ahead.
So Tuesday, we're just gonna have regular class, and then the following.
Well, we have a regular class anyway when we have a quiz. We just stop about a half hour before the end of the meeting to have our quiz. That's
all right, so next Tuesday is just class.
Just a class,
and
no
Thursday.
quiz. The quiz will be Thursday. So the schedule says Tuesday. It'll actually be Thursday. I'll send an announcement out to make it clear to everybody. All right?
Okay. All right. Okay.
So
Thank you.
don't worry. You'll be fine. Everything will be good. All right, guys. So any other questions? Because we're running a couple minutes late. No? I'll stop the recording.